Hey friends! Gen AI is as popular as ever, and with that comes AI agents, a type of Gen AI. Many developers are being asked to implement AI solutions into their projects, so it's no better time than now to start learning about implementing it in a .NET project. And with the cold nights here for many of us around the world, we can start thinking about comforting food we might want to eat on those cozy nights. So join me, Luce Carter, a developer advocate here at MongoDB, as we look at how we can build an AI agent using Microsoft Semantic Kernel, the AI SDK in C#, OpenAI, MongoDB Atlas, and MongoDB Atlas Vector Search to create an agent that will help you decide what you can make for dinner this evening, whether you want to go out to shop for some ingredients, or even better than that, recommend some restaurants to you based on the cuisine that you've asked for, all because you just don't have enough ingredients to cook it. So let's get started. Let's quickly have an overview of what we're going to be building and a little bit of background into how that all works. So our agent is going to be made up of a few pieces. First is a plugin for retrieving a list of available ingredients from a text file. Secondly, a prompt that uses AI to return what the cuisine of the given meal is. And then thirdly, another plugin for searching a collection in our MongoDB Atlas cluster. Now, to explain briefly, a plugin is just a piece of custom code that is marked as available to the AI and be called to achieve some functionality from within the code, such as calling an API or just interacting with some other service. A prompt is also custom, but it builds up text, often with dynamic inputs, that's then used as an input to the AI to carry out the task based on that input. And I'll put a link in the video description below to a fantastic Microsoft Learn course on Semantic Kernel if you want to learn a little bit more about plugins and prompts in detail. And if you'd like to learn more about integrating retrieval augmented generation, or RAG, with Semantic Kernel, you can go ahead and watch the previous video I recorded on building a movie recommendation bot, also with Semantic Kernel, and you'll find that in the video links below. But before we get distracted by hunger, let's go ahead and get started and have a look at what we're going to need to get started. You will need a few things in place in order to follow along with this tutorial. First, you'll need an Atlas M0 cluster, which is our free forever tier, and this will need to be deployed with a full sample dataset loaded. You'll also need an OpenAI account and an API key, which is also free, the .NET 9 SDK installed on your machine, and then the starter code that can be found on the start branch of the GitHub repo that will be linked at the top of the video description. So, in order to make your life easier and to save time, there is some code that's already been generated for you that isn't explicit to this tutorial to just help make your life easier. So let's have a look at what you get out of the box with that starter code. This can be found in the GitHub repo linked in the video description, and it is on a branch called Start. So first of all, we have this data folder, and inside that we have a file called cupboardinventory.txt. So this is just a list of fake lowercase ingredients that you might find in your cupboard. You by all means can go ahead and play around with these ingredients as you wish. You might have some favourite foods or items that you want to add onto that list. Then we have a models class. So this restaurant class will be used later on when we want to search for a potential recommended restaurant. And this is just a standard C# class that's been added with some annotations and attributes from the MongoDB C# driver, which acts essentially as an ODM that maps between your documents and the class. So here we've just got some attributes that just say that we want to ignore any extra elements. So essentially, we might not care about all the fields available in a specific document. We only care about the ones that we've got properties for, so just ignore any others. If you don't have this attribute on and you ignore some fields, it will throw an error. So if you ever find that in your other work, just be aware that you just need to add this attribute. Then you can use a camel case or case convention if you wish, and we have case convention packs that you can configure to specify how to handle names. If the casing convention is different between your properties in your C# class and your prop fields in your document, if they differ across the whole document, you can choose to set a case convention to handle it, so you don't have to specify the specific attribute. But I've gone ahead and done this here because this class was generated with the GitHub Copilot extension, which can actually generate model classes for you. But keep an eye out on our YouTube channel for that, because there will be a YouTube short. But essentially, we've got all these properties here, and they're just the ones that we care about. And then for embedded documents, we have an address class as well inside of here, so that then the driver will automatically map the address class and their properties to the address object here. So you'll then essentially get a sub-object, sub-document, embedded document, whatever terminology you want to use. Then inside the program.cs class, we just have some original code to get started with. So we've got some using statements. Then we have this method here, which is generate embeddings for cuisine. Now, the reason we have this is that we want the code to go ahead and generate some embeddings based on the sample data in the dataset that you will have had loaded, but it won't be in a format the semantic kernel can work with. So we need to just go ahead and generate those embeddings. It will go ahead and create the vector embeddings for the cuisine field, and it'll put it into the format that semantic kernel can work with. That's outside the scope of this tutorial, so to make your life easier, I've just gone ahead and put the code in here so that you have it there available to get started with. And as you'll see later on, we will make use of this, but for now it is just there for reference. I add a very similar function to a previous tutorial, which I'll link in the video description below. So if you want to learn a little bit more about what's going on in here and how you might recreate it, have a look at that video. And that's that. We're ready to get started with writing some code. Because this is a .NET console application using .NET 9, it doesn't automatically come with appsettings.json and appsettings.development.json files like you might see in a Blazor application, for example. Now, you could go ahead and add that in here and configure it in program.cs, but for the sake of a simple video like this, it's excessive. So we're going to take advantage of environment variables. Now, in the video description below, you will find a link to a gist where you will see all the code snippets that will be used today. That will include some export or set statements depending on your operating system to paste to save your environment variables. Now, for the sake of not revealing my secrets, I'm not going to do that here. But as I say, with the first gist in the video description that will give you the snippets that you need to paste in order to save those variables. But once you've got those variables saved, it's then time to start using them in code. So up here, after our using statements, we're going to go ahead and paste that in. So all that's saying is, okay, for the API key, grab this environment variable and do some error handling. So we have to get the API key. There needs to be a value for that. So if it's not there, then throw an argument null exception with a useful error. Then for the model name, rather than throwing an error if they don't specify OpenAI model name, we've gone ahead and just set it to a default of GPT-4o mini because that's a perfectly adequate model to use for this. You can use something else if you wish, but it's just there just in case. So now the only other thing we need to do for this section is to go ahead and update this. So I walked you through briefly what this method was doing in the previous section, but one thing you'll note here is that we need to add our OpenAPI key. Now we've just fetched that from environment variables, so we just need to make sure here that we go ahead and replace that value. So now we can go ahead and run this. So we're going to actually call it. So we're going to say await generate embeddings for cuisine. So as you saw before, this generate embeddings for cuisine method does have a progress bar because it can take a few minutes to process those 1,000 documents. So the best thing we're going to do now is we're actually just going to go ahead and run the application so that we can see it in progress. So if we go ahead here and switch over to our application, we'll be able to see in terminal it's running. So here we are in the terminal. Of course, you could run this from an IDE or Visual Studio Code or whatever you're choosing to use. I'm going to do it from terminal here just because I like running things from terminal. So go ahead and do .NET run and you will see that it will start to eventually run the application. So as you can see, it's now started to process our documents and it's running through all those 1,000 documents. And in fact, if we come over to Compass here we go. So we're here in Compass and you can see that if we refresh the section here, it started to generate that embedded cuisines. So just give that a few minutes to keep processing all those 1,000 documents and then we'll continue. Now we have our sample data with embedding cuisines available. It's time to start setting up semantic kernel so we can make tools available to achieve our goals and also start creating our first plugin. So the first thing we're going to do is we're going to delete this line here that calls that embeddings for cuisine. We've already done that, so we can delete it. Then we're going to paste in this code. So this is going to go ahead and create the kernel, tell it to use OpenAI for chat completion, passing in the model name, and then creates the kernel that we can use later on. If you're using something that doesn't automatically import using statements, just make sure that you've got these semantic kernel related using statements up here. So now we've set up Semantic Kernel, we can start creating our first plugin. So as I mentioned earlier, we have a list of ingredients available in that TXT file, and we can use that to simulate fetching ingredients from an API. So if you've got a really techie smart fridge, for example, you might have an API available to get the list of ingredients that it can see, but we'll just keep it simple. So the first thing we're going to do is create that ingredients plugin that's going to fetch all the ingredients from that file. The agent can then use that to get all the available ingredients before deciding if it's missing any ingredients required to cook the meal that the user has entered. So the first thing we're going to do in the root of the project is add a new folder called plugins. Then we're going to create a new class inside of that called ingredients plugin. So now we have that class created, we can go ahead and paste a method inside of here, and then I'll talk through it. So we're just going to go ahead and add those using statements. So make sure that you've got using system component model and using Microsoft.semantic kernel. So this method here is pretty straightforward. So it's called get ingredients from cupboard. All it's doing is something pretty straightforward, which is just building up the path to find the txt file, then returning all the text in that file to lowercase just to ensure consistency. So that's just standard C# code. What's different here is this annotation. So this is saying this is a kernel function, so it's a function available to the kernel, and it's got that description of get a list of available ingredients. So Semantic Kernel will be able to now use this function. It will understand when it might want to use it, which is when it wants to get a list of available ingredients. So the last thing we need to do then is just actually call that. So we can close this file now, we can come back into program, and after this last call here is just say that we want to use that ingredients plugin, making sure that it adds a using statement. So all it's saying is we want to import a plugin from a type, and a type is a class. In this case, it's that ingredients plugin that we've got. So now the kernel will have access to that ingredients plugin for use later on. It's now time to make the get cuisine prompt. So we need a way to get the AI to tell us what the cuisine of the meal is, and this is where creating a prompt comes in. So there are two ways to create a prompt with Semantic Kernel. We can either do it via two files, so a JSON config file and a prompt text file, or with a YAML file. Now, I don't know about you, but I find YAML very easy to get wrong with its indenting approach. So for this tutorial, we're going to use the former, and we're going to create those two files. So the first thing we're going to do in the root of our project is create a new directory or folder, whatever term you want to use, called prompts. Now inside of prompts, we're then going to create another folder called get cuisine, because that is going to be the name of the prompt. So the first thing that we're going to do then inside this get cuisine is create the first of the two files that we need, which is the JSON config file. So we're going to create a new file, we're going to call it config.json. I won't add it to Git for now. And then we're going to go ahead and paste in this code. So a reminder again, all the code snippets that you're seeing in this tutorial are available in a gist that is linked in the video description. So we've gone ahead and added this code in here. So it's specifying that it's a completion prompt, describing what it does, and then just setting some execution settings. So for example, temperature 0, aka we want it to be very specific. We don't want any creativity around the response that we get back. And then we have the input variables. So as you can see, input variables is an array of objects, and each object has a specific format to describe the input variables. In our case, we've only got the one input variable, which is called cuisine. It has its description to describe what that input variable is for, and then we're saying that it's actually required. So that's the config file. Now we're going to create another file inside that same folder that we're going to call skprompt.txt, and this is the naming convention. This is what you would call a file. Again. And then we're going to paste in this text. So this is just building up the prompt. So you might have heard the term before, prompt engineering. So as you'll see at the bottom, we have a little bit of prompt engineering where we're just making sure it's very specific. So we're saying we don't want any extra words. We just want the single name of the cuisine. And we've even given it some examples. And then at the top, we're describing what it is we want to do. So you want it to return a single word that represents the cuisine of the requested meal that's sent. And then you can see this special format here. So the cuisine is the name of the input variable. It's preceded by a $sign to specify it's a variable, and it's also put inside of these double curly brackets here. And that is how you can take advantage of dynamically inputting different variables at runtime. In this case, a variable called cuisine. So now we need to make the prompts available to the AI as a plugin, and that's slightly different compared to the concept that's called plugins. And so what we're going to do is we're going to go back to our program.cs class, and then after that call to import the ingredients plugin, we're going to paste this code here. So what this is doing is it's just doing some OS agnostic stuff to get the root of where we are, to then go ahead and find the prompt directory. So it's saying create a set of kernel plugins by creating them from the prompt directory. So we let it know where the prompts directory is. Then what it does is it goes through, and for each folder it finds with the corresponding files it needs, it's going to create plugins for those. It'll then be available later in that array that we can use. And just like that, we now have it available to us. So up next, we're going to then create the restaurants plugin. Lastly, we want to create another plugin, and this time it's for restaurants and actually interacting with our MongoDB cluster. So this is the bit that's going to take advantage of the awesome Atlas vector search. So inside our already existing plugins folder, we're going to create a new class, and we're going to call this one Restaurants plugin. Then we're going to add the following using statements and update the namespace. So let's just do that. Still the same namespace. And then we're going to replace the whole class with the following, and then we'll talk through it. So we're just going to copy this in here, and then we're going to paste it. So what this is doing is, again, it's fetching our connection string and our OpenAPI key, because we still need those. Some of this code is going to look very familiar to the code that you saw in the pre-existing method in program.cs, but we're giving it this kernel function attribute here to let it know what it's doing and what it's to be used for. And then we give it this attribute, so we're passing in that cuisine, and that's actually going to be generated from that prompt that we just created. But essentially, we have this description of just explaining to the AI agent what the argument or parameter is going to be used for. So then we build up the memory store like we saw before, with the OpenAI embedding generation. So this is because, just like with the first method, that was generating embeddings for the cuisine against the existing data from the sample data. What this one is doing is being used to generate embeddings for the specified cuisine, because we want to know what we have to have, turn it into vectors for comparison in the vector search. So we build it up so that it can take advantage of it. So we build up the plugin and everything, and then we do that search. So we search through our memory, and we say that in that embedded cuisines collection, we want to search against cuisine, get back 5 results, and anything with a relevancy score of below 0.5 we disregard as not relevant enough. We then create a new list that we then populate by searching through those results. So based on the restaurants that we got back with that search, we want to have a look and just add any restaurants it gets back to that list we created, and just pass it in the information that we care about. So we want the description back, so that's going to be the name and the address, which we populated with the description field. Then from the additional metadata, we also grab the cuisine. Then we just return that list of restaurants. So we now need to go back to our program.cs and briefly just add our new plugin in. So after the ingredients plugin here, we're going to do very similar. We're going to do kernel.import plugin from type, and this one is going to be a restaurant plugin. Just like that. Nice. So now it's there, ready for us to get started with. So now it's time to bring it all together and try it out. Now, the first thing I will mention is that in the restaurants plugin that we just created, in the declaration for the memory store, you would have noticed a reference to an index name called restaurants_index. This won't exist yet when you're following the tutorial, but because we have lots of content already on how to create vector search indexes, I'm not going to include it in this tutorial, but I will include a link to the documentation in the video description, which will show you how to do it. It's very simple. There's lots of ways you can do it, including from Compass, our GUI tool, from Atlas UI, or even from the Mongo shell, MongoSH. So from here on in, I'm going to assume that you have gone ahead and created a vector search index. If you decided not to call it restaurants_index, just remember to come in here and update the name of the index, otherwise you won't get any results back. Okay. So now we're going to bring it all together, and we're going to actually start to build up the pieces we need to interact with the user and give them back information. So the first thing we want to do is we want to tell the AI that we want it to act of its own accord out of the box. So we're just going to specify some OpenAI prompt execution settings, and we're just going to specify that the tool call behavior is auto invoke. Then we're going to add the user interaction. So we're going to say, hey, what would you like to make for dinner? Pretty simple, and then, we'll get back their response as an input string. Then we're going to build up the prompt, and we're going to make use of that input that we've got back. So all this is saying is we want to, using the raw string here, hence the @ we want to build up a list of ingredients based on that ingredients from the cupboard. Then based on what they asked for and the ingredients available, make that decision about whether they can make the meal or not. And then we can actually invoke that prompt. So we can go ahead and put some spaces in here, and we're just going to paste that. And we're saying, okay, well, for the ingredients, we're going to go ahead and invoke a prompt, and we're going to pass it that ingredients prompt that we just built up, and also pass it in that settings that we specified to let it know to just do things automatically. We then have some output formatting. So we're saying, okay, well, for the ingredients results, we get back of what ingredients are missing, just turn them all to lowercase string, and then split them on new lines. And then for each response that starts with the dash, only keep those. So essentially what's happening, and I saw this a lot from testing, was that each time it was bringing back a response in the same format, which was a little bit of text to start with, and then a bunch of missing ingredients separated by the dash here. So this is just handling that, so we only get the ingredients and none of the extra text. And now we want to start having some fun with the user and actually deciding whether they have enough ingredients to make their meal or something similar to it, or whether they should just not bother and go to a restaurant instead. But as well as suggesting they go to a restaurant, we'll use that custom plugin to recommend an actual restaurant based in their cuisine as well. So we can paste in this code here and then we'll have a look through it. So it's just if statement handling really. So it's saying invoke that get cuisine to find out what the cuisine is and let it know that the cuisine variable, the value we're going to assign to that, is going to be the input. Then we're saying if you've got more than 5 ingredients missing, build up a prompt to let it know that we want to use the restaurants plugin to get a restaurant. Again, passing it in the settings to make sure it does it automatically, and then passing it in that cuisine result as the cuisine. After that, we bring it all together and we write out how much is missing and then give them a recommended restaurant that they can go to instead based on their cuisine. If they've only got a few ingredients missing, then we ask it to just recommend a similar dish based on what ingredients they're missing. And otherwise, if they've got everything they need, then it will actually go ahead and use the AI to find a recipe to make that dish and print it out to the screen. Simples. So now we have all the code in place. Let's try it out. So either from within your IDE or in a terminal using the .NET CLI like I'm doing here, let's just do .NET Run. So that's going to go ahead and build it, and then it's going to say, what do you like to make for dinner? So how about we try something like tacos? See what it says. So depending on the model that you're using, it can take a few seconds to run through it, so don't worry too much. Okay, so this has come back and said, based on the ingredients, you probably could just make something else like chilaquiles. I'm not even going to attempt to speak Mexican, but we can run it again, and we can maybe try something like lasagna, and then it will say, okay, we've got most ingredients, but here's what you're missing. So you could keep experimenting with it, and eventually you will find that it will come back and say, okay, well, you don't have enough ingredients. Why don't you go out for dinner? And it will give you a bunch of restaurant suggestions based on the sample data using that cuisine type that you entered. Nice. Woo! And just like that, we've built an AI agent using Microsoft Semantic Kernel, MongoDB Atlas, and Vector Search with OpenAI to build out an application that will let you know what you should cook for dinner tonight, or whether you should go out to cook. Why don't you try experimenting with different foods that you might want to eat, or even the ingredients in the text file to see what recommendations that you get. Or if you've got something like a smart fridge that's clever enough to be able to tell you what's in your fridge, why don't you try integrating that API into the application, so instead of using a text file, it tells you based on what you've actually got in your real fridge. Enjoy your meal!